Okay guys, so we are now in the milling room. This is the cam room and our machinist is here. If you ask Jessica Angel, we're going to go through each of the machines and what they do. It's almost like a product review, their pros and cons. This video is primarily for dentists, but patients are more than welcome to watch it. It's a little technical, it's a little long, but we're very passionate about this. So we've got some zirconia blanks here. Zirconia is the raw material, zirconium oxide, that the teeth are made from. It starts as a very soft material, and it comes in different dimensions. Typically the diameter is standard, it's 98 millimeters, or some machines accept a 98.5 millimeter diameter blank. And the height is very variable because some teeth are longer and some are shorter. So the height goes anywhere from 12 millimeters to 35 millimeters. You can even get 40 millimeter blanks, although it's rare to get machines and clamps that can accept them. For full arches, we predominantly use about 25 millimeter blanks if it's direct to tie-based zirconia without a titanium sleeve. One of the elements here is the cam software. So the brain of the machine, these are all 5-axis machines, so almost all of them. I'll go through the 4-axis ones. There's X, Y, Z axis and A and B rotations, and I'll show you that on one of the machines now. Then there's the tools, spindle and collet chuck, etc. But the machine needs a language to be told how to work, and that language is referred to as G code. There's G and M codes, etc. So that's a programming code which tells the tool how to move and the axes how to move. And we use software, so there's multiple different types of software. This, for example, is Millbox, an Italian company that owns this. They install their post-processor. They work with the machine makers to understand the capabilities of the machine, and they program that into their software, which is the post-processor. There's Millbox, which is Italian software. The Imes ICore machine, they called their software ICAM. So instead of it being Millbox here, it's ICAM, which is really they're white labeling it, you know, putting their user interface on a back end. Same thing, like if you look at this, this is VHF. It's a German manufacturer of machines. If you look over there, you'll see 2 VHF machines, the E5 and the R5. We'll talk about them in a minute. So they have their own front end, which is VHF, but the back end is actually by a German company, cam company, which does just software called Hyperdent. This is a closed solution, which we don't like, because if you want to do custom milling strategies or adjust tools or really adjust anything, you can't. You have to conform to whatever's in there. So the geometries of what you can mill are limited. Then we have Millbox Smart, and we have Expert Mode, which gives us total control over the software. These softwares are very expensive. They're 5,000 to 10,000 euros each, and it's IP really. So that's why you can see there's so many computers here, because each computer has its own software to each machine. Yeah, so you can see here, this is ICAM V5. This is the smart version, which allows us to, in this instance, we've actually told the software to focus a lot of the detailed attention on the front teeth so that our ceramicists don't have to spend a huge amount of time. This is the sintering bar, the supports. This is expert mode, which is a whole programming language in itself. If we look at this, we're able to see exactly how the spindle will move, and we can adjust that for, you know, a plethora of reasons. We won't kind of go into all that now. So here we have the various tools. Different burrs or tools are required for different machines. So then if we go over here, different cases which are ongoing. Over here we have an industrial cam, which is called Work NC. This is a French cam. This is the best actually out of all, because it's completely, wasn't designed for dental. And okay, fair enough, it's the most complicated to use, but also the most flexible in terms of its capabilities. We'll start with the AMM 580. This machine weighs 550 kilos, so it's a wet mill only. So what I mean, you see, I've just turned on the coolant there, so you can see how the coolant works. So if we turn on the spindle, as the coolant hits the tool and mills on the tool, it will make sure that it doesn't, well, catch fire or heat up or anything like that. We can open the door here to go through the options. It's got, we'll open the magazine, 28 different sized tools of various diameters depending on the indication. So we push that back in. And by having such a wide variety of tools, it's got, you know, T-tools, it's got everything. We can mill pretty much any geometry on this. And these are some examples. So you see we've got metal bars. These are titanium. Titanium is a very hard material. So you need a powerful spindle. This spindle is a 2.8 kilowatt spindle. It needs 8 bar of pressure. The tool here is driven by a compressor, so it's not electricity, it's a compressor. And the actual tools themselves are a 6 millimeter shaft. Typically in dental, it's a 3 millimeter shaft, so these are double so that the tools don't break when they hit metal. or when they, engage the metal. That combined with a very flexible cam allows us to do weird and wonderful geometries. We can mill multi-unit abutments on this, and we have done. We've milled custom locators. The vast majority of our jobs are titanium bars, but we like to get creative with this. So how we do that is something like this goes in. This is a 98 millimeter. This particular material is cobalt chromium. It's a base metal alloy, but the vast majority of what we mill is titanium actually. It is subtractive manufacturing, so it starts with a bigger item, removes the titanium, and you're left with something small. These have to be on a concrete floor because there can be no movement. If there's any movement, it'll affect our tolerances. So this is 3 micron level of precision. It's not sub-micron like the Swiss lathes that we have in our other factory, and we'll show you those too, but it's very, very precise. In terms of its axes, so here's the spindle moving down in the Z-axis. So that's axis number 1. Then there's the Y-axis, so in this direction. Then there's the X-axis, and it also has the A. See the way it's rotating? A is rotating around the X-axis, and B, it's rotating around the Y-axis. And because of that, the geometry we can mill is quite complex. So you see it's 180 degrees, fully rotated. So 5-axis, and it's usually 3+2 machining. So it's not simultaneous 5-axis machining, but it doesn't need to be. So that's the AMM 580. So it's a wet mill only. It does not do dry milling. Pricing of this is 100K machine. So, or anything equivalent generally will cost you about 100K, maybe 80K. And we use it predominantly for heavy machining of metals. This is also what differentiates us from other laboratories. We do not outsource any milling, and metal milling is hard, no pun intended. It's hard material, but also the CAM software is hard, the tooling is hard. The consequences of failure are catastrophic because the spindle breaks, the collet chuck breaks, the tools break. If there's any collisions, it's problems. Okay, here we have, this is the Dentsply Sirona MCX5. A lot of these machines are called 5 because they want to emphasize that they have 5-axis milling. There's the tool there. It's only a 3mm tool. And this is an 800 watt, so it's a sub 1 kilowatt spindle. So despite them advertising that it does cobalt chromium, it does zirconia, it does PMMA, it does Emax, it in fact does not do metals. And I can tell you from experience, because we've tried, apart from the fact that the cam is very limited, so the geometries are very limited, it also just doesn't have the torque. Tools break. So just to be aware of that, actually, to the dentists watching, there are many machines. Ivoclar's PM7 claims that it does, VHF's R5, and the thing to watch out for is the spindle above 2 kilowatts. You need 2, 3, 4 kilowatt spindle, or is it sub 1 kilowatt? If it is sub 1 kilowatt, it's not going to mill metal. So this we use mostly for Emax. We put in little ingots, Emax ingots. The main advantage is this is a really easy machine to use. So any entry-level machinist or a dentist just starting their journey on CAM will be able to use this. It's not really designed as a chairside machine. It's for dental lab use, but very simple. Its only advantage. It's got tons of disadvantages. The engineering is poor. It's very expensive. It always leaks around the border. You see this flimsy sealing that it has around the chamber. So because it is a wet and a dry mill, when you turn on the wet mill, it begins to leak. The tooling is limited. It only has a few different tools, but it's easy. It's easy, and they have their own software, which is easy software. So easy. We practically never use this anymore because we're focused on quality. We want to do the hard thing, which is, because we're excited about this stuff, but the better thing rather than the easy thing, But we have it as a spare in case we occasionally go through periods of a huge amount of work, so that we can get through all the work. Price point, these are 50K euros plus. They used to be more, now they're a little less. The R5, right now it's about 70,000 euros. It's a machine made in Germany. It has an automated disc changer on the bottom. So we can open this and open the lid. So it can do 8 discs at the same time. Again, it claims it can do metal, it cannot. I've broken this spindle, I had to replace it. It's good for zirconia, good for Emax. Again, their user interface is simple. And the advantage of a machine like this over something like this is that it can do discs and automatically swap them out. So you can put this on a Friday night, for example, come back on a Monday, and it will automatically mill through like 8 different discs. It's really robust. If you treat it right, it does not break easily, and its maintenance is easy. The software tells you the steps and how often to do them. They have their own, they use a Renfort suction system for the excess zirconia powder, which comes out. But yeah, I would say pros are, it's easy, it's robust. We've had this machine for 4 years now, and yes, our attention to detail is good on servicing it, but apart from the abuses that I've put it through and the team have put it through when it did break, but we were trying to do metal on it, if you stick to zirconia and Emax, it will not break actually. But it is expensive, 70K machine, probably not worth it. It should be a 50K machine. There's loads of competitors now on the market. The only reason they get away with this is, this concept of German engineering, German precision. People like buying German, so we fell into that. So this is their other machine, the VHF E5. This is an interesting machine because they've patented this concept of an air tool. So for all these machines, you need a compressor, and compressors take up space. They are difficult to account for, and so you got to also plumb them, etc. So this machine was designed for chairside use because it's relatively light. It does not require a compressor, so it's an electric-driven collet chuck and spindle. So it's a 700 kilowatt spindle, or even 600 maybe. Yeah. So a very weak spindle, but it doesn't need to be strong because look, this is what it's milling: zirconia powder. So this does only dry milling and only zirconia. Because Emax ingots are actually quite hard. Price point, this is about 28,000 euros right now as of the time of shooting this. So it's an okay price point. And it's got a C-clamp, which allows for access to the facial, so facial milling. The disadvantage is that it's only got, see here, 3 zirconia tools. If you're doing zirconia, it's only got a few tools. It can also do PMMA, but it's dry mill only, so no wet milling. Again, pretty robust. If you calibrate it, it works. If you use the VHF cam, no issues with that. But it's limited. There's no 0.3 millimeter tool for fine finishing or anything like that. But yeah, decent. Yeah, we use this quite a lot. Here we have, this is actually in progress, so you can zoom in and see. This was Aidite's competitor to the VHF E5, which they call the 500E. Currently it's milling a zirconia disc there. It's got more tooling. The software is more advanced here. They use Millbox software. And you can see, this is actually the live G code that we can see, C710, G751. So this is the programming for every step. For every step, it's showing the time. So this is currently 45 minutes. It's got the tool T2, how quickly the spindle is rotating, the feed rate, how much it takes at each go, and it's also showing X, Y, Z, and A, B machine positions. So this has a software in it. Again, a sub 1 kilowatt spindle. It does require, you can see here, there's a suction there. These are voltage transformers, which sometimes are required, but not for us. There's a Renfort suction in relation to the E5. But price point, this is more attractive in pricing to the E5, but it is more complicated to use, and it does have its own compressor. Now, this is our kind of most expensive and most technologically advanced machine here in the lab. This is Imes ICore's latest machine, which they call the 350i X Pro. It's a modular system because you can add on this portion. This is the disc changer. So you see here, there are blanks to allow, as soon as you're finished one job, get the next job going. Again, you can see there's the X, Y, A, B, and Z axis, so 5 axis. They sell their own suction unit in relation to it and their own coolant. So this does both wet and dry. So if we look here, this is where we fill up the coolant. It's got a very powerful spindle. On the manual it actually says 3 kilowatts, but it's 3.4 because it's even more powerful than their 650i series machine. This is their latest invention. Disadvantages to this is that the user interface here, so this has its own Windows software inbuilt. You can see it's kind of a large bulky machine and it requires its own stand. They're not so flexible about any part of their workflow, so they're like the Apple of milling units. They insist that you buy their own stand, their own suction unit, their own cooling unit. It can mill anything, metal, zirconia, Emax, PMMA, denture faces. Because of the 0-point clamping system, it's very attractive to dentures actually. So this is very unique, this 0-point clamping system. You can put 250 kilos of weight down on this clamping system and it won't affect it. Why that's significant is that you get repeatability. So if you want to take, for example, a denture base, mill it and then remill it, it will continue the program from the very last step. That's for the teeth. So from that point of view, it's very attractive. They do both C-clamps and circumferential clamps, and there is an extremely wide array of tools. You see there's room for 150 different tools here in terms of the virtual tool magazine. The physical tool magazine, it only has 20 tools, but that's more than enough. Here it's warning us that the T19 tool and T18 tool are expired, so we need to change those out. The user interface is a bit kind of old here. It doesn't really lend itself kindly to those who aren't comfortable with software. You have to manually load everything up here as actual files. So it's do a better job on the software, and they're due to come out with a better interface, but they actually have already for their 150i and 250i. This is smaller machines, but not yet for their 350i or X Pro. So really, really expensive. This is a 100K plus machine when you consider all the add-ons, but very robust. I have colleagues who've been using this machine for, not this particular one, because this one came out last year, but its predecessor, just the 350i, for 15 years plus. So then we move on to the AMW 400S. This is a wet milling machine, and it's actually 4 axes only because it's really designed for lithium disilicate, for Emax. It's very good for Emax, it's fast. Millbox software is robust, the spindle is quite powerful. It's a heavy machine. This is a 250 kilo machine, this is a 150 kilo machine. It doesn't move while it's milling that hard object. It's got good tool selection and it's appropriately priced. So really it's only suitable for milling centers or labs who specifically we do a lot of Emax, a lot of veneers. It's not a good choice for someone who's looking for versatility. Nor is the AMD 500E actually, because this is a dry only mill. It's probably actually why the price point on the R5 and these kinds of machines is so high, because they kind of stress that you've got the versatility between the wet and dry milling. Although after wet milling you have to completely dry the chamber out before you do dry milling, which requires patience and diligence, and machinists sometimes skip the part and then you can have complications. So a lot of labs, they separate out their wet and dry mills. They don't mix materials within the mills. So yeah, quite a good machine for Emax. We'll probably get more of these as we ramp up specifically for Emax. Here actually you can see how the C-clamp allows the tool access to that facial as it's doing more and more with each feed rate. So that's the milling center done. That's the software that we use, Vevi Dental, our laboratory software. Yeah.